This morning, several people asked me about this particular problem. So I would like to go through the construction of this mechanism, although I do have to warn you, as I've said in class on numerous occasions, that there are different ways of creating these joints, and what I do necessarily is not what you may be doing. But as I go along, I will advise you of what other options you've got so that you can try it by yourself. Okay? Right now, let me just explain to you how I'm going to do this thing. So there will be a base. Let's call this thing a base, and there is a rod here, okay, and a wheel, and from the wheel sticking out a pin, which is going to slide up and down this slot. Okay. So all right, let's go ahead and make it. No particular dimensions are taken here, so let me start with assembly design to make my job easier. So insert new part. Okay, let's give it some time. All right, let's call this thing the track. Properties, I'll call it the track. This is the place or the ground where the wheel is going to roll on. Track. All right, and let's make it. Double click on this. On a convenient plane, on that plane, vertical plane, I will sketch. The track is basically just a rectangle that has been padded. And I'll make a little hole here because eventually I'm going to put my rod along which that pin is sliding at this location. That's going to be obviously revolutionary. So exit and pad it. Okay, I've got to go to part design, and where's the pad? Here's the pad, and I'll use the default size 0.787. Okay, good. So now we're going to insert the rod. So insert, new part. I'll call it the rod. Right click, properties, rod, and rod. Okay, let's make it. On a convenient plane, on that plane, I use a sketch. Well, why don't I project this circle to make my job easier? There we are. Okay, normal view. Let's do the rest of the rod, and the rest of the rod is, something like this. I'll clean it up in just a second. There we are. Wrap it around. Okay, so just to make it look better, so I make this thing and that thing concentric. Now notice that it collapsed. Oh, not coincident. That's not what I meant. Cancel. What I meant was concentric, not coincident. Sorry. This curve, this arc, and that arc, concentric. There we are. Okay. And now in here there is also going to be a slot. Okay. So what's the best way of doing this thing? Perhaps let me show you a way to do this, not necessarily the best way or the fastest way. So I'm going to select this, control that arc, control this arc, and control that arc. Let me show you something that you have not seen in class, so you should try all these things. Let me see now. Here there is offset. No, not there. Where is the offset? Right there. Offset. So offset it inward. Okay, good. Okay, the only thing is that I did not want this thing to stop here, so let me see if I can move that thing. It looks like I can, so I have to clean it up here. So let me see for a second. Let me Yeah, let me draw a line like that. Okay, remember, I'm making this thing too complicated. You do it the way you want to, and then a quick trim. Get rid of this, and get rid of that, and get rid of this, and this, and that. And there is my slot. Okay. Let me see now. Exit, and we're going to do a multi-path. Multi-path. That. Okay, why is this thing selected? Sketch isn't valid for feature you want to create. I'm not sure why. That being the case, there's more than one way of skinning a cat, so here's what I'm going to do. What I'm going to do is, okay, fine. Get rid of all the stuff that we don't want. Actually, we can do a, yeah, let's do a path then. Sure, let's do a path. Oh, I see. Looks like they're open profiles. When I did this thing, there were some open profiles. Let's go clean it up. So don't do it. Let's clean up our sketch. So tools, sketch analysis. Let's go to the sketch. Let's go to the sketch. And right there, these guys, see that? Right there, these lines should go. When I quick trimmed, I didn't see these. And now we can do multiply. If I had done tools sketch analysis, it would have told me that there are some isolated curves there that we had to go to move. So that's great, no problem. Exit and multipath, no problem. So this is the inside slot. So I want to stay slot, so I'll put a 0. This is the outside, so I'm going to make that thing. How about making it? I don't know, 0.5 inches. 0.5 inches. And this is the circle at the other end, which I want it to be a pin. So let me make it 1. Okay. So there we are. You can see that. All right. We're going to assemble this thing in a minute. So let me separate these so that we're not confused. So let me see now. Let me translate in direction, I suppose, X. Direction X. There we are. Eventually we're going to flip this around and stick it into that hole. All right. So now we're going to insert the wheel. So insert new part. Insert new part. Call it the wheel. Right click properties. Let's call this thing the wheels. Properties. The wheel. And the wheel there. All right, let's make it. So let's see now, on a convenient plane, on that plane, I will sketch because I can see how the wheel is going to be positioned with respect to this rod. Okay, so let's draw a circle. I'm going to clean it up. Okay. First of all, let me make this thing tangent to this. I'm going to shift it up. Okay, very good. Okay, and then I'm going to make a little pin here, on this circle. So well, I can put it right in there, but it really doesn't matter. So just draw a circle there. Okay, and exit, and do a multipath. That one is going to be the this thing. So why don't I make that thing maybe 1 inch? And this is going to be the wheel itself. So I'll make it 0.5. There we are. That pin is going to go into that slot. Now I don't know because I want this thing eventually to lie on that. So let's do some measurements here before we proceed any further. I may have to adjust these, okay, and we can do that later. After we assemble, we can adjust it. Okay, very good. So let's go here. All right, so we're going to anchor the track. Let's try. I'm going to push this thing inward, doing this and that, and update so that it pushes it in. Okay. I may have to delete this later on, depending on the joints that are going to be created. This is going to, if you do plane to plane, it's going to be a planar joint. Now let's stick this hole, this guy into that hole. So being this axis and the axis of that, and coinciding this plane and that plane, that's going to make a revolute joint. Eventually it's going to become a revolute joint. So I just want to make sure that these are actually pointing in the opposite direction. I'll flip this. Okay, good. All right. At some point I have to put this pin inside of that slot, but let's not worry about it right now. Don't forget to save. File, save management. Save as. This is the product. Save as. Yeah, let's go to the desktop. New folder. Sample. Test. What question was that? I think it was question 3. Let me see. 2. Okay. So sample test. Let me rename this thing. Test question 2. Question 2. Summer 19. Okay. All right. Let's put it in there. All right. So right. We're gonna go to digital markup. Get the magic wand out. New mechanism. Auto create. So let's see what kind of joints you've got. My guess is that you have a planar joint because of these two, and you have a revolute between this and that. We'll find out. Yeah. But actually, for some reason this came out to be cylindrical, and although it may work, I would have preferred if it was revolute. And there's 2 ways to fix it, but yeah, might as well do that right now. I don't like the way this thing went, so I'm going to delete this. I'm going to create a revolute between this axis and that axis, and this plane. Yeah, this plane and that plane. Okay. Well, let's see. There must be some other constraints here. Oops. Well, try it again. Oh, did actually create it right there. But where's the joint? Okay, so let's do the following. I'm going to delete these constraints. My joint, although I made it, but somehow it kind of disappeared. Let me translate these. See now, translate these to make my job easier. When I create the joint one more time, I don't exactly know what I did here. So let's see now. Back to DMU, revolute, this axis, and that axis, and this plane, and that plane. Yeah. I don't know, something happened last time, so there we are. Okay. Now, I want to put this inside of that track. So first thing, my suggestion in class was make sure that these are in the vicinity of each other. So let me do a rotation about that axis. So move it up there. Okay. All right. And it looks like when I padded things, I was the right size. It looks like this was this was maybe 1, and the pin was 1 too. All right. So in order for us to create a roll curve joint, the two curves must be slide curve joint or point curve or roll curve. This curve and that curve must be touching, and yeah. So right now they are not. What I'm going to do is I'm going to put that pin on that surface, and the way to do it is by contact. See that? Contact is straight. So this plane and that plane, and if internal doesn't work, try external. Well, let's see. Let's update and see what happens. Oh, obviously it didn't work. So let's go and change it to external. Update. There we are. Now you might say, well, wait a minute, this is too big. This is fine. It's gonna slide. I can create the slide curve. There's no problem. All right. Now the only thing that's left to do is to do a roll curve between this guy and that guy. Slide curve between this and that. So let's go to digital mockup. Get the slide curve. This is the slide curve between this curve and that curve. I mean, if this is bothering you, you can make this hole smaller so that there's no interference there. But that interference is not going to come into the picture as a mechanism. Okay? And then a roll curve between this curve, this circle, and that line. So let's see. Where's the roll curve? Roll curve between this curve and that line. And we say OK. All right, see that? There is a problem here because it says that there is a difference, a 1 millimeter difference. So actually, these are not tangent to each other. If you look at it closely, see that? There's a gap here. Can I push it in? And because I made a slide curve here, that may cause a problem. But let's cancel that. Let's see if I can push this thing towards that. I may have to do some readjustment up here. So let's go to digital assembly design. Make a coincidence between this plane and that plane. Still there is a diff, and I have a suspicion that it's because of these sizes. Okay, now what's the best way of solving this thing? So let me see for a second. Okay, it has to do with this length. If this is supposed to be sliding on that, all right, this is where we have to do a little bit of detective work. Okay, let me find out what is what is this distance. That distance is 1/2 inch, so the pin must have been 0.5 inch. I don't know what it was. 0.5. Okay, the pin must have been 0.5. So let's go fix it. All right, so we're gonna go to the wheel, multi-path. Let's see. Okay, so this was 0.5 and this was 1, so it makes that guy 0.5 inch. So I'm surprised that these things cannot do not mate. So let me see, what can we do to fix this thing without too much work. Let me also see what the length of this pad was. Yeah, I'm surprised because these are all correct. This was this guy was 0.5. That's weird because there seems to be a distance here. Okay, you know what? Why don't we do the following? Let us go ahead and delete that slide curve. Let me go to DMU. I'm going to delete the slide curve. Okay, good. Let's push this thing. So that they mate. So assembly design. Where are we? Okay. So coincidence between this plane and that plane. Okay. What constraint do we have there? Constraint is, we already have something there. Is it this one? Yeah, it's right there actually. It's right there. We're going to delete this. Coincidence between this line and that plane. And update. Wow. Oh yeah. Okay, that was an artifact. Look, from here you can see that. Oh, okay, these two guys are not touching. That's what it was. So as a matter of fact, you know what? Let me get my slide curve back. There. Okay, I have to bring this thing back and put it on that face. That's what was missing. So contact between this and that. If one doesn't work, we try the other one. Okay. See, this was, when I was looking at it from that angle, I thought that there was a distance here, but the distance was because actually it was in the vertical direction. And I'm surprised because I made those things tangent, but okay. So let's do our roll curve. Roll curve is right there between this and that. He would not do it before because there was a distance between them. Now it's okay. Degree of freedom is 1. Excellent. So let's make that roll curve, for example, length driven. The total length of this is probably, 11 inches. So that's fine. Okay, good. Mechanism can be simulated. And here is there. Right there. Okay, couple of comments. First of all, be prepared to do things like this on the test. Because, yeah, I mean, you may have to fix things. There's no doubt about it. But our parts are simple. You have plenty of time. Make sure you can fix it. Now, another way of doing this problem was instead of creating a slide curve between these two, I could have done a point curve. You can create a point at the center, for example, of the circle, and a line halfway between the two ends of the slot, and put the point on that curve and make sure it goes up and down. Another way is to create a point on this circle and make sure it travels along that edge. Another point curve. So you can do the point curve, center of the circle, and a line here, or a point on the circle and that edge. Okay. If this happened to be just happened to be rectangular, then among other things, you could have also done a prismatic joint between the edge of that rectangle and the edge of the slot, etc. Different ways of doing the problem. Okay. So good luck. Try this and.